Okay, so here in lesson 6.5, we've used the Pythagorean theorem forever. Now you're going to prove it. Okay, it's a pretty quick one, but there's, two basic approaches that we're going to cover to prove it. So here we say, okay, we've got a right triangle A, B, and C, and you want to prove that the square of AC and the square of BC, if they sum together, are equal to the square of AB, which is the hypotenuse. So the first thing it's telling you to do, you just follow the instructions here, but it says construct an altitude CD to the hypotenuse AB. So here's your altitude from C, you're going to construct it down here to D. Okay. Then it says applying the right triangle altitude similarity theorem, what can you conclude? So here you have to go back, you might need to go back and take a look at the right triangle altitude similarity theorem, but the idea being that these triangles that are formed, that'd be ADC and triangle BDC, they are congruent to triangle ABC. So then what this is telling us, it's telling us that you can write a proportional statement between the longest leg and the hypotenuse because they're similar, right? These are similar triangles. You can write a proportional statement that's between this hypotenuse of this big triangle, right, and the hypotenuse of this smaller triangle, CDB. They are going to be proportional in the same way that any other of the corresponding parts of those triangles are proportional. And when it says rewrite it as a product, what you're going to do is you're going to multiply both sides by the denominator to write that. Okay? Then write a proportional statement describing the relationship between the shortest leg and the hypotenuse of triangle ABC and ACD. So you're going to write the same proportional statement. Then and then you're again going to multiply by the denominators. You're writing a same proportional statement but just using these parts. You're going to again multiply the denominators so that you have a product. And then what you're going to do is you're going to add those two things together. Those two statements get added together. So in other words, line up the left, okay, and line up on the right. And when you do, you're going to add down, okay, and add down, and you'll have an equals in between. And what you're going to find is you're going to have a common factor that you can pull out, and you're going to be left with dB plus AD. And what you're going to realize is that dB plus AD is equal to AB. So the square is going to go right back into, if you put it back in there instead of writing dB and AD, you're going to put in AB and you're going to square it, and you should end up with AC squared plus CB squared is equal to AB squared, which was the Pythagorean theorem. I know there's some some thinking to do on that with algebra, but just let me know if you have any questions. I think you should be able to do it. Okay, so let's see. Let me scroll down a little bit more. Now you're going to do it again, and this time we're going to you're going to walk through all these questions and answer the questions based on this diagram. So the area of the larger square is B plus A times B plus A, or you can go the other way, A plus B times A plus B. And don't forget you have to FOIL that. So you're going to end up with something like A squared plus 2AB plus B squared, something like that. And then the total area of the four right triangles, remember a right triangle is base times height, so it's going to be A times B, and it's 1/2 base times height. And so you have 1/2 AB. When you look, you're going to have 4 of those, so these two together come together. Their areas, this triangle and this triangle, you could imagine pushing them together, you'd have a rectangle. And so that would be 1AB, and here's another rectangle, and it'd be 2AB. So that'd be the area of the four right triangles. Okay, what is the area of the smaller square? Well, it's a square that is simply C by C, that's C squared, right? What is the relationship between the area of the four right triangles, the area of the smaller square, and the area of the larger square? Well, you're going to take the area of the larger square, which is like what? AB squared plus 2AB plus B squared, and then I guess what you're going to do right here is you're just going to think about what the relationship is. So the area of the larger square is going to be, or the area of the smaller square is equal to the area of the larger square if you took away the 4 right triangles, right? So start with the area of the larger square, subtract the area that represents the 4 right triangles, you'll end up with the area of the smaller square. And if you work that through with algebra, you end up with, a squared plus a squared plus 2ab plus b squared minus 2ab is equal to c squared. And just working that through with some algebra, you end up with a squared plus b squared equals c squared. So now the converse of the Pythagorean theorem is going to be done on this next part. So what can you conclude about the measure of angle 1, the measure of angle 2, and the measure of angle 3? You can see they've got them lined up here. They're basically a linear pair between the 3 of them, right? If you do angle addition, you're going to add up the 3 of them. Are going to form together a linear pair. They're going to be supplementary, so you can conclude that they measure 180 degrees, right? And then use the triangle sum theorem to determine the measures of angle 1 plus the measure of angle 2. So the sum of these two angles, 1 and 2, these two angles must sum to 90 degrees, right? Because we, we know that they are in a right triangle, so 1 and 2 and this right angle. So together they form 180, take away the 90, and you end up with 1 and 2 being equal to 90. So knowing that 1 and 2 is equal to 90, what do you conclude about 3? You can conclude that 3 must be a right angle. So what does angle 3 tell you, the measure of angle 3 tell you about the quadrilateral? If it has 4 right angles in there and all the sides are equal to c, it must be a square. What is the area of one of the right triangles? And that's going to be 1/2 AB again. What is the area of the quadrilateral inside the square? It's going to be c squared, and then you're going to go through doing the algebra again the same way and proving it. This time not knowing that c was a square, until you prove first that it had to be a square. Okay? And that's really the only difference in this last part here. And if you have any questions, let me know.